Hello all, in today's lesson we will talk about another numerical integration formula, that is Simpson's 1 by third rule. In the previous lesson we had seen how we can solve the numerical integration using trapezoidal rule. So let's talk about Simpson's 1 by third rule. To derive that formula, again we will take the help of the Newton-Cotes quadrature formula, as we have taken the help of this formula in the deriving trapezoidal rule. We will derive Simpson's 1 by 3 with the help of the same formula. Let me tell you that Simpson's 1 by 3 rule is for n is equal to 2. That means for the polynomial that are linear or quadratic in the terms, in the order, and the higher terms are ignored. So let's begin and derive the Simpson's 1 by 3 formula. As we already know, to get the integration, numerical integration, the large integration is subdivided into smaller intervals where the interval size will be 2. So let us assume that if we have x0 to xn, this interval can be subdivided by x0 to x0 plus twice of h fx dx. Then we'll sum plus, and now we'll begin with x0 plus twice of h to x0 plus 4 times of h fx dx, plus and so on. And this way we will take the intervals with 2. The last one will be x0 plus n minus 2h x0 plus nh fx dx. So we have divided the larger integral, the whole integral, into smaller sub-intervals. The sum of these smaller sub-intervals will be the larger integral, that is x0 to xn fx dx. So now we need to get these smaller sub-intervals from the Newton-Cotes quadrature formula. To get this first smaller sub-interval from the Newton-Cotes quadrature formula, we will take here n is equal to 2. So now let's substitute n is equal to 2 into this formula. So this will become x0 to x2 fx dx is equal to n is 2. So this will be 2h. Within the bracket this will be y0 plus 2 upon 2, that will be 1. So this will be del y0 plus 2 into 2, 4 minus 3, that is 1. 2 upon 12 is 1 upon 6. This is 1 upon 6 del 2 y0. And as this is for n is equal to 2, we need to keep the terms only till degree 2, and we will ignore the terms with higher degree 2. So we will ignore all the terms after degree 2. So now this will be 2h y0 plus del y0 plus 1 upon 6 del 2 y0. Now we need to solve this. Let's substitute the values of y0, del y0 and del 2 y0. So y0 will remain same. As we know, the del y0, this is the forward difference formula. This will be y minus y1. We had already seen this formula in the forward difference table. Then del 2 y0, so this will be, let me write 1 upon 6, del 2 y0 is y2 minus 2y1 plus y0. So this is the formula for the del 2 y0. Now we will solve this, and this will be 2h y0 and minus y0 will be cancelled out from here. So we can keep this 6 out. So this will be 1 upon 3, and 6 will be in the LCM. So this will be 3 y1 as y0, and minus y0 will be cancelled out. So this will be 6 y1. This will be 6 y1 plus y2 minus 2 y1 plus y0. And this is coming to be h upon 3. 6y1 minus 2y1 will be 4y1, y0 and y2. So this is y0 minus plus 4y1 and plus y2. So this is the result for the x0 to x2 fx dx for the first subinterval. In the similar way, we can get the second subinterval. So let me write the second subinterval. This will begin from x2 and will go to x4 fx dx. Will be according to this formula, we'll have h upon 3, and as we are shifting two intervals, so this will be, instead of y0 we will have y2, plus instead of y1 we will have a y3, plus instead of y2 we will have y4. So this is from x2 to x4, h upon 3 y2 plus 4 y3 plus y4. Similarly, we can get the third interval and also we can get the last interval. And as you know, at summing of all these subintervals, we'll achieve this final formula. Now, this x0 to xn fx dx will be equal to, I'll write the first solution. This is h upon 3 y0 plus 4y1 plus y2, plus the second interval as we had evaluated. This is h3 y2 plus 4y3 plus y4. Let me write one more term for this, plus h3. Now this will be y4 plus 4y5, as we are moving two intervals, n is equal to 2. So y2, y3 and y4. Instead of y2, we will have y4. On the place of y3, we will have y5. On place of y4, we will have y6. So this is y6. Plus and so on. And let me write the last term. In the last term, we will have h upon 3. This will be y of n minus 2 plus 4y n minus 1 and plus y of n. As we can see, h by 3 is common in all the terms. So we'll take h by 3. y0, in whole the series, y0 is occurring only once. So we'll take y0, and we can see yn is also the single term that is coming once. So we'll take y0 plus yn in one group, plus. Now let's see which are the terms coming 4 times. As we can see, 4y1, 4y3, 4y5 and so on till 4 of yn minus 1. So we are keeping all these in one group. This will be 4y1 plus y3 plus y5 and so on till y of n minus 1. Next we can see y2 and y2 coming twice, y4, y4 coming twice. Similarly y6 will come twice till yn minus 2. So we'll keep all these in one group. This will be twice of y2 plus y4 plus and so on till y of n minus 2. So now this is the Simpson's 1 by 3 rule. As we can see that in the common term it's h upon 3, 1 upon 3. That's why it is called as Simpson's 1 by 3. So this is the Simpson's 1 by 3 rule to get the numerical integration. So now let's get to an example and see how we can use this formula to achieve the integration. So this is the example. We have to evaluate integral 0 to 6 1 upon 1 plus x squared dx using Simpson's 1 by 3rd rule. So first of all, we need to create the data set table for this. Before that, we need to take a decision that how many intervals we will take. Like in trapezoidal, I have told you the number of interval has to be the multiple of n is equal to 1. Here in Simpson's 1 by 3rd rule, the number of intervals must be multiple of n is equal to 2. That means we can make either 2 intervals, 4 intervals, 6 intervals, 8 intervals, 10 intervals or so on. So in this question, we have values from 0 to 6. What will be the valid choice? Let's say we can take 6 intervals. Whether the 6th interval is a valid choice? Yes, because 6 is the divisor of n is equal to 2. Can we take 5 intervals? No, we cannot take 5 intervals because 5 is not the multiple of 2. Can we take 7 intervals? No, we cannot take 7. We can take 2, 4, 6, 8, 10 and so on, which are the multiple of 2. So let's make the intervals. Let's make the 6 intervals. So just to get 6 intervals, as we can see that this is lower limit and this is the upper limit. So just to get the h, we have 0 plus 6 upon the number of intervals we have decided. The number of intervals is 6. This will come 1. So h is coming 1. So now using this h1, we will generate the data set table for this. So now the data set table for this will be where we'll have x and we have the values of f of x. What is f of x in this question? If we compare this question with 0 to 6 f of x dx, we can see that f of x here is 1 upon 1 plus x square. So for every x we'll have f of x. As we can see that we have the interval h as equal to 1. So we'll begin with the lower limit 0. 0 plus 1. Next will be 1. 1 plus 1 will be 2. 2 plus 1 will be 3. 3 plus 1 will be 4. 4 plus 1 will be 5. And 5 plus 1 will be 6. Now we need to find out fx for each value. Now let's say at 0, 1 plus 0 square, this will be 1. So at 0, fx will be 1. Now at 1, this is 1 upon 1 plus s square. This is 1 upon 2 coming 0.5. So at x is equal to 1, we have 0.5. At x is equal to 2, we have 1 upon 1 plus 2 square. This is 1 upon 5. It's coming 0.2. So at 2, this is 0.2. In the same way, we'll complete this whole table. Now as we have got all the values and we can see that here this is y0, this is y1, this is y2, y3, y4, y5 and this is y6. Now we need to apply the Simpsons formula, substitute all the values and need to achieve the integration. So this integration x0 to xn fx dx will be equal to h upon 3. What is h in our case? H is 1. So this is 1 upon 3. What will be y0? The first value. This is 1 plus what is yn? The last value. This is yn 0.027 plus 4 times. We have to take y1, y3 until what? We have y1, y3 and y5 here. So we have 3 values. This will be 0.1 plus 0.5 plus 0.1 and plus 0.0385. Remember, we have to go till y5 only, as here in this yn is y6 and you can see we have to reach to yn minus 1, that is y6 minus 1 is y5 plus twice. So we have y2, y4 and so on. So what values we'll have? We'll have y2 and y4 only, because this is going till yn minus 2. Yn is y6, y6 minus 2 is y4. So we have 2 terms here, y2 and y4. This will be 0.2 plus 0.0588. So we have substituted all the values. We will calculate the result, which is coming 1.3662. So this is the final result of the numerical this is integral of 0 to 6, 1 upon 1 plus x square dx is coming 1.3662 with the help of the Simpsons 1 by 3rd rule. We'll study Simpsons 3 by 8 rule in the next lesson. Thank you so much.